Albert Einstein, he wondered, he said, how is it possible that mathematics, which is, he thought, a product of human thought, does so well in explaining the universe as we see it? He said that the fact that mathematics can really describe the universe so well, in particular physical laws, is a gift.
Is God a mathematician? I know, it sounds a little absurd. But believe it or not, it's actually the title of a famous book that was written by the astrophysicist Mario Livio. In this book, Livio talks about just how mysterious mathematics really is, to the point where even scientists themselves are left confused by it. How is it possible that mathematics can predict and explain the universe with almost unbelievable accuracy? Is it all just a coincidence? Or is it evidence of a great mathematician behind it all?
The mathematics that is needed to describe those laws isn't natural to us. And the question has naturally occurred to many people, why is mathematics so potent?
Well, that's exactly what we're going to talk about in this video. How can mathematics, the very language scientists use to understand the universe, end up being the thing that confuses scientists themselves? So get your brain ready, because some of the ideas we'll talk about might genuinely blow your mind. Let's talk about it.
That is the mind of God.
If you think mathematics is nothing more than a bunch of numbers and symbols written on a piece of paper, well, you're wrong. Because behind all this confusing stuff we hated in school lies a much bigger mystery. The mystery that time and time again in history, these numbers and symbols have predicted things even before humans ever discovered them. Take the God particle, for example. Before it was finally discovered by scientists in 2012, its existence had already been predicted nearly 50 years earlier by Peter Higgs, using nothing but mathematics.
Did you use any machines or any special equipment?
A pencil and paper.
A pencil and paper? That's all you used?
Well, that's all you need for writing equations.
Or take black holes. The first actual image of a black hole wasn't captured until 2019. But long before that image was ever taken, its existence had already appeared in Albert Einstein's equations back in 1915.
We now have visual evidence for a black hole. And it is also consistent, the shape of this shadow, to the precision of our measurements with Einstein's predictions.
The same goes for gravitational waves. They first appeared in Einstein's equations nearly a century before technology became advanced enough to detect them. And those are just a few of the many examples out there. Did we discover all of these things because of mathematics? Or is mathematics itself the underlying code of the universe? This question even led Nobel Prize-winning physicist Eugene Wigner to write an article titled "The Unreasonable Effectiveness of Mathematics in the Natural Sciences." Read that title one more time. The unreasonable. Those words didn't come from a philosopher or a religious leader. They came from a Nobel Prize-winning physicist, someone who understood mathematics better than almost anyone else. And to understand why a Nobel Prize-winning physicist described this phenomenon as unreasonable, we have to start with a number I'm sure all of you remember from school, the number pi. Hopefully you still remember the formula for the area of a circle, pi times r squared, where r represents the radius of the circle. And as for pi, most of us know it as 3.14, right? But here's something you need to understand. 3.14 isn't actually the true value of pi. This is the real value of pi. And as you can see, the digits just keep going. So how many digits are there? As of today, computers have calculated more than 105 trillion digits after the decimal point, and they still haven't found the end. So why does it have so many digits? Well, the full explanation would get pretty confusing for most of us. But the point is, pi is an infinite number.
So to write it out in its decimal form, you'd have an ongoing series of digits starting with 3.14159 and continuing forever. So when did they finally figure out the exact value instead of just estimating? Actually, never.
Now some of you might be thinking, so what? It's just a number with no meaning. Who says? Because if you think about it, almost everything in our universe naturally tends to take the shape of a circle or a sphere. The sun, the stars, the planets and their orbits, water droplets, cells, even the atoms that make up everything around us, they all point back to circles. Or if you go back and look at the physics equations you've learned over the years, you'll notice that pi is everywhere. And that's what makes it so mysterious. It's everywhere. So many things depend on it, yet we've never actually known its true value. And that raises another question. Why? Why does this single number keep showing up in places that seem to have nothing to do with one another? Is it all just a coincidence? Or was the universe written in the language of mathematics from the very beginning? A language that even today, we still don't fully understand.
This simple set of counting rules can describe the physical universe. That is astonishing. So on a sheet of paper, you can have all the fundamental laws of reality on just one sheet of paper. Now that's unreasonable. That is shocking.
But guys, the weirdness of pi is nothing compared to this sequence of numbers. This is the Fibonacci sequence. Back in 1202, an Italian mathematician named Leonardo of Pisa, better known as Fibonacci, published a book called Liber Abaci. Now, I have no idea what was going through Fibonacci's mind at the time, but in one chapter of this book, he tried to describe how rabbits reproduce using mathematics. Pretty weird, right? What does rabbit breeding have to do with math? Whether Fibonacci realized it or it was just a coincidence, but his observation ended up leading us to one of the biggest mysteries in mathematics. Fibonacci imagined an ideal pair of rabbits that produced another pair every month. And as the population kept growing, the number of rabbit pairs formed this sequence: 1, 1, 2, 3, 5, 8, 13, 21, etc. And here's the interesting part. This sequence turns out to follow a simple mathematical pattern. Every number is the sum of the two numbers before it.
So 1 plus 1 is 2. Now 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. And you keep going like this.
And what makes it so fascinating is that this sequence of numbers, whether Fibonacci discovered it by accident or not, doesn't just appear in rabbit populations. It shows up all over nature. Take flowers, for example. If you look closely at a flower, you'll notice that the number of petals isn't random at all. Some have 3 petals, some have 5, others have 8, 34, and those are all Fibonacci numbers.
You know, look at flowers, for example. So there are many flowers that have 3 petals like this, or 5 like this. Some of them may have 34 or 55. These numbers occur very often.
But one of the strangest examples is the sunflower. The seeds inside a sunflower grow in spiral patterns. And if you count those spirals, whether they curve clockwise or counterclockwise, the numbers always belong to the Fibonacci sequence. And you'll find the same thing in pineapples. The patterns on a pineapple's skin also form spirals. And if you count them, they turn out to be Fibonacci numbers as well.
So we've got 8 spirals going in one direction and 13 spirals going in the other direction.
The same pattern appears in pine cones, cabbages, even the way leaves grow on plants.
And if those numbers sound familiar, that's because Fibonacci numbers.
Over and over again, the numbers keep pointing back to the Fibonacci sequence. And this is what has left scientists speechless. How can plants know mathematics?
So do plants know math? The short answer to that is no.
Plants can't do math. They can't count. So why is there this connection?
But here's where it gets even stranger. If you take each number in the Fibonacci sequence and arrange them into adjacent squares, then draw a curve through each square, you'll end up with a spiral. And that spiral looks almost identical to the spiral patterns we see throughout nature.
The spiral is the most common shape found in nature. We see it on a grand scale in galaxies and on a small scale at CERN, where they shoot particles through superheated liquid nitrogen.
And the mystery doesn't end there. If you divide one Fibonacci number by the one before it, the bigger the numbers get, the closer the ratio gets to 1.618. Do you know what that number is? It's called the golden ratio. And just like the Fibonacci sequence, the golden ratio seems to show up everywhere. Take the human body, for example. If you measure the distance from your belly button to the top of your head, then compare it to the distance from your belly button to your feet, the ratio is roughly 1.6. Or measure the distance from your elbow to your shoulder, then compare it to the distance from your elbow to your fingertips. Once again, the ratio is about 1.6. The same pattern also appears in the position of your eyes, your nose, your eyebrows, even your lips. That's why the golden ratio has often been used as a standard of beauty.
They are in golden ratio proportion. Let's look at her nose. So Kelly's nose is also a good length in golden ratio proportion.
And it doesn't just appear on the outside of our bodies. It also shows up in the proportions of our organs. Eventually, the golden ratio even inspired humans to create art. It can be found in paintings, architecture, graphic design. It has even become part of the curriculum in design schools.
What I learn and look at when I look at these images is that I know something about the people that made them. I know that it is important to them to reflect nature's pattern.
And everything we've talked about so far is just the beginning, because the weirdness of mathematics doesn't stop there. Take tree branches, for example. They all look completely random, right? But if you look a little closer, you will notice the same pattern repeating itself over and over and over again. And you'll find the same thing in tree roots, the blood vessels inside your body, the airways in your lungs, lightning, even the way rivers branch across the landscape. This is what's known as fractal, a pattern that looks completely random but turns out to follow a hidden mathematical order. But we will talk about fractals in the next video, because if we dive into them right now, this video would end up way too long, and I'd probably lose my mind trying to edit it. So let's put everything on the table. There's pi, a number that appears throughout the laws of physics. There's the Fibonacci sequence, a pattern that shows up in flowers, leaves, and even fruits. There's the golden ratio, found in the human body, in art, and throughout nature. Even the patterns that seem completely random turn out to follow mathematical rules. And somehow, all of them lead back to one thing: the language of mathematics. So let's go back to the question we started with. Is God a mathematician? Of course, science can never answer that question. But one thing seems undeniable. The universe is written in the language of mathematics. And if the universe really is written in the language of mathematics, then who wrote it? Well, I don't know. But Nobel Prize winner Eugene Wigner once wrote, "The miracle of the appropriateness of the language of mathematics for the formulation of the laws of physics is a wonderful gift which we neither understand nor deserve."